Hello everyone, my name is Aditi and my team members for this project Sushant and Megha. Our topic for DSP project is designing filters using GUI, that is graphical user interface, in MATLAB. Next, our problem statement was to design the filters using GUI in MATLAB, and the aim of the project was to study the GUI in MATLAB. So first of all, we will see what is the filter. In signal processing, a filter is a device or process that removes some unwanted components or features from a signal. Filtering is a class of signal processing. Most often, this means removing some frequency or frequency bands. Filters are widely used in electronics and telecommunication, in radio, television, audio recording, radar, control system, music synthesis, image processing, and computer graphics. There are many different ways of classifying filters, and these overlap in many different ways, like nonlinear or linear, time variant or invariant, causal non-causal, analog or digital, discrete time or continuous time, passive or active time, continuous time filter, infinite impulse response, that is IIR, or finite impulse response, that is FIR. Next, so we will see what is the digital filter is. In signal processing, a digital filter is a system that performs mathematical operations on a sampled or discrete time signal to reduce or enhance some certain aspects of that signal. This is in contrast to the other major type of electronic filter, the analog filter, which is typically an electronic circuit operating on continuous time analog signals. The main DSP operation is digital signal filtering, that is the change of the characteristics of an input digital signal into an output digital signal with more desirable properties. The system that performs these tasks are called as digital filters. The application of digital filters include the removal of the noise or interference, passing of certain frequency components and rejection of others, shaping of the signal spectrum, and so forth. Although filters are easily understood and calculated, the practical challenge of their design and implementation are significant and are the subject of much advanced research. Next is IIR filter. IIR filter are one of the two primary type of digital filter used in a digital signal processing applications. IIR means infinite impulse response. The advantage of IIR filter is IIR filters can achieve a given filtering characteristic using less memory and calculation than a similar FIR filter. There are various types of IIR filter, that is like Butterworth filter, Chebyshev filter, elliptic filter, Bessel filter. In this project, we tried to implement Butterworth IIR filter using GUI in MATLAB. Next, what is GUI? GUI means graphical user interface. Is a pictorial interface that allows the user to use an application without understanding the language. This is done by providing intuitive controls. The controls are the buttons that the user clicks to obtain a determined output. GUI is an event-driven program. This is because it acquires input at any given time, and uses the callback function to execute the program and gives the result. Next is the implementation. These are some screenshots of our implementations. As you can see, these are some screenshots we have implemented. I will show you the implementation in MATLAB. So this is the MATLAB. I will open the file for the MATLAB. This is the file. If I run this, this is the main page, or we can say that menu page of for our project. If I click on the Butterworth high pass filter, then this GUI will created, and if I press the calculate button, then it will plot all the graphs for IIR Butterworth IIR filter, that is high pass filter. The magnitude, as you can see, high pass filter magnitude response, high pass filter impulse response, high pass filter phase response, and poles and zeros. And if I click on the menu button, then it will be back on the first page, that is this menu page. We have designed this using a using the guide in MATLAB. Guide is the inbuilt function in MATLAB in which we can create these designs for our GUI. I will show you one more filter. We will select the stop Butterworth stop band filter. You can also change these frequencies, but I have not changed in this program. If I press this calculate button, then you can see that the program will provide the all the responses for the Butterworth stop band filter. So this was our project. This was our project. These are some reference. These are some reference, and the conclusion of the project was uh, MATLAB provides really a good environment for creating the GUI. This is because it automatically generates the code for the design of the GUI. The generated code also contains comments that make it easy for the programmer to understand what the code entails and better organize the callback functions. We will shortly see what is the callback function. A callback is a function that you associated with a specific GUI component or with the GUI figure. It controls the component behavior by performing some action in response to an event for the component. Okay, I will show you in MATLAB callback function in the MATLAB. Okay, so as you can see that this is the callback function in the MATLAB. If I run this, MATLAB calls the callback we associated with the clicking that button, and callback then gets the data. If suppose I want to plot the graph for this, then as an example, suppose a GUI has a button to trigger the plotting of some data. When the user clicks the button, MATLAB calls the callback we associated with clicking that button, and the callback then gets the data and plots it like this. You can see this is the callback function. Okay, and we have also used some other comments in this. I will briefly tell you what are the other comments we have used. We have used this HW frequency FREQ Z frequency Z, that is for returns the endpoint frequency response vector H and corresponding angular frequency vector W for the digital filter with transfer function coefficients stored in the B and A. This butter this butter function is typically for design a low pass, high pass, band pass or band stop Butterworth filter depending on the value of F type. This is as you can see, this is high, this is the F type, means filter type. If you put here low, then it will be the low pass filter. And this is the IMPZ is the inbuilt function for the impulse response of the function. So this was our project, and it was really good experience to explore the GUI in MATLAB. In MATLAB, it's really interesting to explore GUI because MATLAB automatically generates the code for the GUI that we created. So it is really easy to understand all the comments, all the code and it's really useful for programmer design the GUI. And in MATLAB, uh, in newer versions of MATLAB, App Designer is the function for the GUI, and in older version of MATLAB, guide was the function for the GUI. So thank you.